And we're recording. So today we're going to talk about how to subtract linear expressions. This is Chapter 5, Lesson 7. And we're on page 403. We're going to skip this page right now, and feel free when you have time you can watch the video, but since I returned the quizzes and everything, we're just a little short on time. So we're going to go on to page 404. On page 404, it talks about how do you subtract linear expressions. Here we go. When subtracting linear expressions, subtract like terms. Use zero pairs if needed. Okay, so what we have here, you have 6x plus 3 minus 2x plus 2. Here is a model of what they have. The model of 6x plus 3. Then they take away 2x and they take away 2 of the 1's. So what do you end up with in the model? You end up with 4x plus 1. Let's look at another model. In number 2, you have 2x minus 3, so you have 3 red ones to indicate minus 3, minus x minus 2. So you take away one of the x's and you take away 2 of the minus 2's, you end up with x minus 1. Now, on this, I think you're not going to want to have to draw models of these problems. It's much easier if we just multiply by a negative 1. And that's what I think I'm going to show you how to do right here. So let's just, you understand how to do the models? Sort of. This is going to be easier. All right. Our goal when you do these expressions is to get rid of your subtraction signs. Once you get rid of subtraction signs, you can use the commutative property. So the first thing you're going to do is get rid of this negative, the subtraction signs. Add the opposite, add the opposite. Any questions on what I just did there? This is where the trickiness comes in. See that negative subtraction sign? You're going to add the opposite. Now this is what you do. That opposite is a negative 1 now. You now have a negative 1. You are going to multiply a negative 1 times the 2x and a negative 1 times the negative 7. So let me write this down. You now have 5x plus negative 9 plus negative 1 times 2x is negative 2x plus negative 1 times negative 7 is positive 7. Do you see what I did there? Now, if you are watching it, please go ahead and draw the arrows where we distributed. The negative 1 was distributed to both items in there. Now it's easy. Yes, we can do the commutative property. Everything is plus. So now it's easy. You have 5x plus negative 2x is 3x. And negative 9 plus 7 gives you a negative 2. 3x plus negative 2. Or 3x minus 2. Does everyone have this written down? Okay, if not, go back and watch my video. Now let's look at letter B. The same thing. Step 1, get rid of the subtraction signs. Add the opposite, add the opposite. Put a little star so you know what you're doing here. There's a subtraction. Add the opposite. And put a little 1 with it so you know to do the distributive property, okay? So, we have 6x plus negative 10 plus negative 1 times 2x, which is negative 2x, plus negative 1 times negative 8 is positive 8. Any questions on that? Good. Now, circle 6x and minus 2x. That will give you 4x. Let's put our constants in boxes. Negative 10 plus 8 is negative 2, or 4x minus 2. Any questions on that? Yes?
How do you get that positive 8?
Negative times negative is positive. That's fine. I'm glad it's been a while since we've been working with our integers, and that's a good question. Negative times negative is positive. Connor.
So the subtraction sign in the middle, when you made it negative 1, does that just make the 2x negative?
Well, it does, because you multiply the negative 1 with the distributive property. Negative 1 has to visit 2x, and negative 1 had to visit negative 8. Okay?
Is that because the positive 8
Yes.
was the negative 2?
Yeah. Negative 1 times 2x makes it a negative 2x, and negative 1 times negative 8 made it a positive 8. All right? Those are the hardest types of problems you're going to be doing for today's homework. Let's go on now to the next page, 405. Here is another example with models. I think the models are more confusing than doing the equation. So I am just going to skip the model, and we're going to go and practice doing C and D with what we did a while ago, okay? All right, so let's go on to letter C and D. Right away, you notice, oh, we're subtracting them. I'm just going to put a little star by each one of these to remind me I have to distribute a negative 1 to both of the terms in that parenthesis. All right, so here we go. Step 1, get rid of the subtraction signs. Add the opposite, add the opposite, add the opposite, which is going to be a negative 1. I'm not seeing you write anything down. I'm very concerned. Okay, now we can, since we have all plus signs, we can go ahead. This will be 3x plus negative 2 plus, now we have to distribute, negative 1 times 5x is negative 5x plus negative 1 times negative 4 is positive 4. Everyone okay? Good. Now we identify our like terms. 3x plus negative 5x gives me negative 2x, and negative 2 plus 4 is 2. So you end up with negative 2x plus 2. Any questions? Yes?
So you're just trying to find, like, simplify it with it, so then, so you're not, like, trying to solve it or anything?
Right, you can't solve an expression because it doesn't have equal signs. Later on, we'll go back to solving equations. But these are just expressions, all right? We're just simplifying an expression. All right, letter D. I put a star by it because it's a subtraction, and I want to remember I have to distribute a negative 1. First, add the opposite, and now I have to add the opposite, and it's going to be a negative 1. Then I take my negative 1 times negative 2 and my negative 1 times 2. My technique is to draw the arrows, because if you draw the arrows, you're not going to forget to multiply both terms. Some of you will forget to multiply your terms, but if you draw the arrows, it helps you to remember to take care of both of the grandkids in the parentheses, okay, the terms. Yeah.
So negative 1 times negative 2x is positive 2x.
Correct. Yeah. You're getting it down now. Good. So now we have 4x plus negative 4 plus negative 1 times negative 2x is positive 2x plus negative 1 times 2 is negative 2. All plus signs, so we can combine like terms. 4x plus 2x is 6x, and our constant of negative 4 plus negative 2 is negative 6. So 6x plus negative 6, or 6x minus 6. Any questions? Doing okay. All right, now let's look at example 4. It says when subtracting integers, you add the opposite or the additive inverse. Kids, that's what I've been showing you in all the other examples. It says the same process is used when subtracting linear expressions. All right, so here they did the negative of 3x is negative 3x and the negative of 1 is minus 1. The way they show it here, I think, is more confusing than the way that I do it with the other problems. Now, you can look at this and try to figure out what they do, but in the past, when I've taught it the way the book shows it, the kids forget negative signs, and they're not as careful. I think the way I do it with circles and boxes right now is really easier than lining it up like this. And I think I'll continue doing that as opposed to showing you that way. Okay, so let's go and practice doing E and F with my technique, okay? All right. Oh, subtraction. I remember I'm going to have to do my distributive property here with a negative 1. So step 1, kids, I'm going to put this on pause. All right. Now, on this, let me unfreeze the screen. You should end up with 4x plus negative 2x is 2x, and negative 3 plus negative 7 is negative 10, or 2x minus 10, or 2x minus 10. Either one of those would be right for letter E. For letter F, 5x plus negative 2x is 3x. Negative 4 plus negative 3 is negative 7. So 3x plus negative 7 or 3x minus 7. Any questions? Good. Now we are applying this to word problems. Let's go to page 406. And we're going to be focusing a little more on word problems here in the future. It's a long word problem, but you can do it. Here we go. A hat store tracks the sale of college and professional team hats for M months. The number of college hats sold is represented by 6M plus 3. The number of professional hats sold is represented by the formula 5M minus 2, or the expression. Write an expression to show how many more college hats were sold than professional hats. Then evaluate the expression if M equals 10. Well, this is the expression, 6M plus 3 minus 5M minus 2. Okay? Now, I'm going to go ahead. I don't like how they do it this way. I like doing it the other way. Get rid of your subtraction signs. Negative 1 times 5M, negative 1 times negative 2. So you're going to end up with 6M plus 3 plus negative 1 times 5M is negative 5M plus negative 1 times negative 2 is positive 2. Now, Brady, write that down. 6M plus negative 5M equals M. And 3 plus 2 is 5. Yep, that's what they have. M plus 5, M plus 5. Now it says M equals 10. So 10 plus 5 equals the answer 15. 15 more college team hats were sold. Okay? Now, let's do the guided practice, and then I'll tell you what your homework assignment's going to be. All right, in number 1, step 1, get rid of your subtraction signs. Only one of them. Add the opposite. So 2x plus 4 plus negative 1 times negative x makes that, yes.
How'd you get, so in the word problem, how'd you get it down to just M?
Here I had M plus 5. but then it tells you that m equals 10 in the words. So then I replace m with 10, and 10 plus 5 is 15.
And then, like, how'd you get, like...
How did I get m plus 5?
Yeah.
6m plus negative 5m is 1m. Okay, I could keep the 1 in front of it. And 3 plus 2 is 5. So you could have, if you wrote down 1m plus 5, I'd count that right too. All right? Okay. And sometimes kids, keep the 1 in front of there. If that helps you to keep things straight, that's fine. You don't have to not have the 1 in there. The 1 sometimes just is helpful. Now, 2x plus 4 plus negative 1 times negative x is positive x. Negative 1 times 5 is negative 5. Now, combine your like terms. Let's do the circles and boxes. Circle your 2x plus x is 3x, and 4 plus negative 5 is negative 1. Okay, good. You're getting that written down. Any questions on the answer, 3x plus negative 1 or 3x minus 1? Either one would be counted correct. Any questions? Yes?
So if you basically did negative 1 times negative 1?
Negative 1 times negative 1x, yeah.
Okay.
And then don't forget, I also took negative 1 times 5.
Yeah.
All right, now let's go to number 2. Get rid of your subtraction signs. And that'll be a negative 1, add the opposite. So, 6x plus 9 plus negative 1 times 7x is negative 7x plus negative 1 times negative 1 is positive 1. Now you circle and box or combine like terms. 6x plus negative 7x is negative x, or if you want to keep negative 1x, that's fine. 9 plus 1 is 10. So if you wrote down negative 1x plus 10 or negative x plus 10. Any questions? If you had 10 plus negative x, I'd also count that right too. Or 10, yeah. Because of the commutative property, you can move them around. There are lots of different possibilities. Now, are we ready to do the word problem? Okay. The number of runs scored by the home team at a baseball game is represented by x plus 7. The number of runs scored by the visiting team is represented by 3x minus 7. Write an expression to find how many more runs the home team scored than the visiting team. Well, it's home team minus the visiting team. X plus 7 minus 3x minus 7. Okay? Now, that was the home team, wasn't it? Yeah. All right. Get rid of your subtraction signs. Add the opposite. Add the opposite. We have x plus 7 plus negative 1 times 3x is negative 3x plus negative 1 times negative 7 is positive 7. All right, combine your like terms. X plus negative 3x, or 1x plus negative 3x is negative 2x, and 7 plus 7 is 14. So you end up with negative 2x plus 14. Yes?
Isn't it x with x stuff?
Is what?
X is with...
Now, after we solve this, then evaluate x for when x is 6. So now, since we've simplified it, we're going to replace x with 6. So, negative 2, because it tells us what x is in this problem, negative 2 times 6 plus 14.
Negative 12.
Plus 14, and the answer is 2. Any questions? All right. This is what I want you to do for homework today, or tonight, classwork today. On page 407, you're going to do all 9 problems. Page 407, I want you to do all. And let's see, do I have anything over here? I don't really like number 10. For those that would like a challenge, on page 409, number 24. So if you'd like to do a challenge, number 24 on page 409 is a good challenge. In fact, all of the problems on 409 are somewhat of a challenge. They're a little harder than the other ones, but let's just practice doing these problems on page 407, 1 to 9, and then to go back, we didn't do the problems on the adding linear expressions. I want you to go back to this lesson, add linear expressions, and these are a little bit easier. I want you to do, this is page 399. We're not going to do all of these. I want you to do 1, 3, do number 7, and number 9. So on page 399, you're going to do 4 problems. 1, 3, 7, and 9. Okay? Any questions? All right, so that's 9 plus 4, that's 13 problems, along with the 1 challenge problem. Yes? Not today. All right, we had a little issue of getting everyone in the room on time, so not today. I'm going to walk around the room to see if anyone needs help first.